Linear systems in three variables. We will learn to determine whether an ordered triple is a solution of a system of three linear equations with three variables. And then we will learn how to solve a system of linear equations with three variables, and then also be able to identify inconsistent and dependent systems of equations with three variables. A linear equation with three variables is of this form, where A, B, C, and D are all real numbers and not all of them are equal to 0. Now, every solution in this equation is an ordered triple of the form x, y, z. And that is the point that makes the equation true. And moreover, when you graph this equation in three variables, the graph is a plane. So in solving system of linear equations in three variables, all the points that are solution to one equation form a plane in three-dimensional space. And by finding what planes have in common, we'll find the solution to the system. When we solve a system of three linear equations represented by a graph of three planes in space, there are three possible cases. The first case is when all three planes intersect. We have here an orange plane, a dark blue plane, and a light blue plane. So notice that these three planes here intersect, and they intersect at one point. Now the point for which all three planes intersect is the solution to the system of linear equation. And we call this system a consistent system, and the equations are independent. Now the second case is when all three planes do not intersect. If they do not intersect each other, that means all three planes are parallel. They have no points in common, and we call this system an inconsistent system. And in this case, there is no solution to the system of linear equations in three variables. Now, it is also called an inconsistent system, the case wherein two planes are coincident and parallel to the third plane. In this case, the planes still have no points in common, and still we have no solution for the system of linear equations in three variables in this case. And also for the case wherein two planes are parallel and the third plane intersect these two planes here, the system is called an inconsistent system because all 3 points here will have no points in common. So there is still no solution to the system of 3 linear equations in this case. And in this case too, there is no solution to a system of linear equations in 3 unknowns when the graph of the 3 planes look like this. Each plane intersects the other 2, but all 3 planes do not have points in common. Now the third case is when we get infinitely many solutions. We get infinitely many solutions when 3 planes intersect in one line. And we call this system a consistent system, and the equations in the system are dependent equations. We also get infinitely many solutions for the case when 2 planes coincide each other and the third plane intersect the 2 coincident planes, and they intersect in a line. In this case, we call the system a consistent system, and the equations are dependent equations. And lastly, we get infinitely many solutions when all three planes are coincident. And we call this system a consistent system, and the equations are dependent. So as mentioned, the solution of a system of linear equations with three variables are of the form x, y, z, an ordered triple. And to determine if an ordered triple is a solution to a system of three equations, all we need to do is substitute the values of the variables into each equation. Now, if the ordered triple makes all three equations true, then it is a solution to the system. For example, determine whether the ordered triple -2, -1, 3 is a solution to the system of linear equations with three variables here. To determine whether this ordered triple is a solution to this system, we will need to substitute the value of the variables here into the system. The first number here is x, the second component is y, and the third component is z. Hence, x is equal to -2, y is -1, and z is equal to 3. We will need to substitute these values into each of the equations here. So for the first equation, x minus y plus z equals 2, we have -2 minus, and then you change y to -1 and substitute 3 to z. And then solve this side, you get 2. So this equation is satisfied. That means this point is on this plane here. Then check the second equation. The second equation is 2x minus y minus z equal to -6. Verify if when you substitute x here by -2 and y by -1 and z by 3, will you get -6? So plugging in these values to the variables here, we get 2 times -2 minus -1 minus 3. 2 times -2 is -4. And then this becomes plus, so plus 1, that's -3. Minus 3 is -6. So therefore, this equation is true. That means this ordered triple is also on this equation here. And lastly, we consider the third equation, 2x plus 2y plus z equals -3. And then we replace the x here by -2 and the y here by -1 and the z here by 3. And then we verify if when we simplify this, this should be equal to -3. So if we multiply 2 times -2, we get -4 plus 2 times -1 is -2. So -4 minus 2 is -6 plus 3 is -3. So therefore, this equation is also satisfied. So in this, we're able to show that the ordered triple -2, -1, 3 satisfies all equations in the system. So therefore, this ordered triple here is a solution to the system of linear equations with three variables. Another example. Determine whether this ordered triple is a solution to the system. To verify this, we will need to substitute the values, each of the values here for x, y, and z in the system. In this case, x is equal to -4, y is equal to -3, and z is equal to 4. And we will plug in these values into each of the equations in the system. So for the first equation, we have x minus y plus z equals 2. We plug in x. For x, we plug in -4. And for y, we replace that by -3. And for z, we replace it by 4. So if we simplify this, -4 minus -3, that is -1. Plus 4 is +3. Now 3 is not equal to 2. That means that this ordered triple here is not on this plane here. So even if you don't complete this, because you already have seen that one equation is not satisfied by this ordered triple, you can go ahead and make the conclusion that this ordered triple here is not a solution to the system of linear equations in 3 variables. Now let's consider a method on how we can solve a system of linear equations in 3 variables. In this lesson, we're going to consider the elimination method to solve a system of linear equations with 3 variables. So to do this, we follow the following steps. First step, write the equations in standard form. If there are any coefficients that are fractions, clear them. And the next step is eliminate the same variable from 2 equations. So to do that, you decide first which variable you will eliminate. Then work with a pair of equations to eliminate the chosen variable. You could either multiply one or both equations so that the coefficients of that variable are opposites. And then you add the equations resulting from step 2 to eliminate one variable. Now, third step, just repeat step 2 using the 2 other equations and eliminate the same variable as in step 2. So you have to pick the same variable and eliminate that same variable that you have chosen in step 2. Then now, once you've done step 2 and step 3, you actually have come up with 2 new equations. And then you form a system of 2 equations with 2 variables. And then you solve this system, again using elimination method. Then use the values of the 2 variables found in step 2 to find the third variable, and then write the solution of an ordered triple. Then if you want to check, you can check the solution, the ordered triple, by plugging into the equations, the original 3 equations. To illustrate this, let us consider the given system here. We have a system of 3 linear equations in 3 variables. We will solve this using elimination method. So the first step is to make sure that the equations are in standard form. Now, the equations here are in standard forms and there are no fractions. Then go ahead and proceed to step 2. So before that, you label first each of the equation here. This is your equation 1, equation 2, equation 3. Step 2 is to pick which variable to eliminate from the 2 equations. For instance, we can eliminate y's from equations 1 and 2. Now, if you eliminate y here, notice that you would need to have a 2 here before you can eliminate y. So you can do that by multiplying equation 2 by 2. So multiplying equation 2 by 2, we have this. This becomes 2 times 2x is 4x, 2 times y is 2y, and 2 times z is 2z. So we simplify that. Then we can add the two equations to eliminate y. So adding the two equations, we have x plus 4x is 5x. This is 0. And then z plus 2z is 3z, equal to 3 plus 8, which is 11. And then we'll label this new equation as our fourth equation. And then step 3, we just repeat step 2 using the other equations and eliminate the same variable, so the same y variable. So to do that, we consider equation 3 here and then pair that to either equation 1 or equation 2. So for instance, we pair equation 3 to equation 1, and then we eliminate the same y variable in equation 1 and equation 3. And we can obtain that by multiplying 2 to the first equation to get negative 4y on the coefficient of y. So multiplying 2 to the first equation and then simplifying it, we have 2x, so 2 times x is 2x, negative 2y times 2 is negative 4y, and z times 2 is 2z, and 2 times 3 is 6. Then we will add the two equations. We have 5x, 2x plus 3x is 5x, this is 0, and then 2z plus 3z is 5z, and 6 plus negative 1 is 5. And then we call this new equation our fifth equation. The next is to consider the fifth and the fourth equation. And then we will solve the system of two linear equations here. So to solve this, we can eliminate either x or z. Now the easiest is to eliminate x because they're already the same coefficient here. You can then multiply equation 5 by negative 1. So multiplying equation 5 by negative 1, we have negative 5x minus 5z equal to negative 5 for your equation 5. And then just copy equation 4. Then you add the two equations. So adding the two equations, you eliminate x, and then you have negative 2z equals 6. And then you divide both sides by negative 2 here to solve for z. Z is equal to negative 3. So we now have a value for z, and then we can do backward substitution to solve for the two other variables. Now to do that, we can substitute this value of z here to either one of the two equations here, because these two equations are already in terms of x and z only. So if you plug in z, for instance, to equation 4, you can solve for x. So let's go ahead and substitute z, which is equal to negative 3, into equation 4 to find the value x. So we have 5x plus, and then replace z by negative 3 equals 11. And you solve this. This is equal to negative 9. Then you transpose that negative 9 on the other side of the equation. You have 5x equals 20. then divide both sides by 5, you get x equals 4. So now you have the value for x, and you also had the value for z already. Then you can then use one of the equations here in the original equations to solve for y. So we can plug it in to, for instance, equation number 2. Let's plug in. You can pick any equation, so we'll just pick equation 2. So we plug in the values to equation 2. We replace x by 4 and z by -3, and then solve for the equation here. So 2 times 4 is 8, and we have -3 here equals 4. Then you combine these two. 8 minus 3 is 5. That's equal to 4. Copy 4. Transpose 5 on the other side. We have y equals 4 minus 5, and that is equal to -1. Hence, we have y equals -1. And now we have the ordered triple as the solution to our system of linear equations in 3 variables. And that's the ordered triple: 4, -1, -3. Now let's consider another example. Solve the system of linear equations in 3 variables and write your answer as an ordered triple. So we begin by labeling our equations. This is equation 1, equation 2, and then equation 3. And then we decide which variable to eliminate from probably equation 1 and equation 2. So in this case, the easiest is to eliminate z. So we will eliminate z from equation 1 and 2. We can eliminate that by simply adding the 2 equations. So adding the 2 equations, we have 2x plus x, 3x, y minus 2y, so y plus -2y is -y, and -z plus z is just 0. So we don't write that anymore. And then 1 plus 9 is 10. We call this our equation 4. The next is to consider the remaining equation, that's the third equation, and then pair that to either equation 1 or equation 2 to eliminate the same variable z. So we will eliminate z from now equation 3, and then you pair that to either 1 or 2. So I suggest that you pick equation 1 because this is already negative. So I'll do equation 1 and 3. Eliminate the same variable. So I'll copy equation 1, 2x plus y minus z equals 1. And then the third equation is -3x plus 2y plus z equals -7. And then you add the 2 equations. You have 2x plus -3x is -x, and y plus 2y is 3y. Z plus z is 0, so you don't need to write that. And then 1 plus -7 is -6. And then we call this our equation 5. So now we're able to reduce it to a system of 2 equations in 2 variables. So let's write down 3x minus y equals 10. That's our equation 4. And then we have negative x plus 3y equals negative 6. This is equation 5. 5, 4. Then we will decide which variable to eliminate from here. So maybe we can go ahead and eliminate x in the equation. So we can do that by multiplying equation 5 by 3. Multiplying 5 by 3, we get negative 3x plus 9y equals negative 18 for equation 5. And then let's copy equation 4. 3x minus y equals 10. And then you add the two equations. So 3x plus negative 3x is 0. You don't need to write that. Then negative y plus positive 9y is 8y. And 10 plus negative 18 is negative 8. Then you divide both sides by 8 to solve for y. Y is equal to negative 1. So we have y equals negative 1 from here. So y is negative 1. Then solve for x from one of the equations here, from equation 5 or equation 4. So let's just go ahead and plug it into equation 4. 3x minus, and then you replace y by negative 1, by the value that we have here for y. So y negative 1 equal to 10. And then solve the equation. This becomes 3x plus 1 equals 10. Transpose 1 on the other side of the equation. You have 3x equals 9. Divide both sides by 3. You have x equals 3. So we now have the value for x, and that is equal to 3. And then we plug in these two values here to one of the equations in the original given. So we can pick probably equation number 2. We will plug in these values to equation number 2. We have x, for x it is 3, and then minus 2 times y, which is negative 1, plus z is equal to 9. Then you simplify. So you have 3 plus 2 plus z is equal to 9. Now 3 plus 2 is 5. So you have 5 plus z equals 9. And then you solve for z. Z is equal to 4. Therefore, the solution, which is an ordered triple, is, write down x first, 3, and then y, negative 1, and the z is 4.